So I'll connect the transistors. Okay, so we've assembled the parts together now. You can start. Yeah, sure. So like I said, the machine has been in a state of rest before, so you have to calibrate first so that it can work optimally. So this is the interface of the machine now. So then you come to settings, calibrate. So this is the measurement space. So you come to settings. So then you take your calibrating rod. And then you hit on.
And you are saying zero-inch transistors on that. Then can you see zero-inch?
You can see there is error, so it means I've not calibrated yet. Then you try again.
Calibrate. This can be as a result of different things. Probably the calibrating rod has been used and has not been cleaned for a while, or there's an issue with the cables, or there's an issue with the connector. You understand? Or while he's putting it, when he's connecting, when he's trying to calibrate, probably his hand slipped off. It's not well connected. So we can have this kind of issue. Can you see? Successful. Then you click on the mark here. Okay. And you go back. Then you go to measurement. That's when you start to use it.
Also, another thing, sometimes even if after changing all these things and it's still showing error, you can just apply little coplant.
Coplant.
You understand?
Coplant.
A little one and put it to
Earlier.
it. So after changing the cable, after doing any adjustment and it's still giving you error, you can just put it to coplant on the connecting rod. So now we go to the measurements now. So this is the interface for measuring your UPV. So this is the option here is pulse velocity. So like you mentioned earlier, we have different kind of method. We have indirect method, we have direct method, and semi-direct method. The popular ones are direct method and indirect method. The direct method is when you have both surface. If it is exposed, the both surface, so that you can place one at the end, you can place the other at the end. So in that place, advisable you use what's it called, direct method. But the indirect method, this is when you use a part length of 120 millimeters. That's 1.2 meters.
Between the two transistors.
So between the
120
center to center, between the two transistors, you place it on your structural element, and then you conduct the test. So it means here there's no place we can use the direct method because we don't have any exposed surface that we can. So here we are going to use what's it called, the indirect method, and the part length we use for our indirect method is 120 mm. So I will change the part length. If you convert 120 mm to meter, what do you have? 0.120. So now the machine, based on this distance now, that's how it is going to generate your pulse velocity. You can see it will be showing us transmission time or transit time. So what's the formula of velocity? The formula distance over time. So it is based on that formula. It is taking the time to travel between that path length from that receiving transducer to the this thing. So over the time, this distance over that time, that's how you get your velocity showing here. So that's just the principle behind it. So can I use this?
Let's make use of this general place.
Okay.
Though it's not a structure.
So we need
We are going
coplant.
to use a surface. We are going to assume that it's a structural element that it's there. You understand? Then we'll use the pondit. Then
Can we
use.
take it to that column?
We should take it to this column here. Even though it is rendered, then we still.
Maybe.
We have to carry it. Okay.
Okay.
So you have to play.
So before you also start the test, as you are like you have to rename this thing. Let's say you are on column 1 and you're on ground floor. Like you have to name so that when you want to download your result, you're able to identify okay, this for particular this is on ground floor, this is on second floor. So you can let's say can name this Unilag. Building department.
Just play. Hold on.
So with this now, there will be no mix up when you're downloading your results for analysis.
Okay.
So this is column 1. So you apply your coplant.
Because you have an
Because this
uneven
surface is not smooth.
then we use the
I'm
coplant.
not putting in your mouth now.
Are you ready?
Yeah.
Okay.
So sometimes we go with now what's it called? Measuring tape for accurate measurement for the 120 mm. So
Are you seeing this? So this is the it doesn't matter. This is the frequency to show. Then this is the velocity. Understand? Then in that case, if you want to save the value, you press this,
It's still reading now.
yeah, you save now.
which is save.
So you just look for a consistent value that's very, very consistent. Then you
So
save.
then you save. Then you change the this thing. I've saved the
That's
first one.
transmission time,
I've
not
saved the
that's
first one.
not the UPV. This is the UPV. 6.8
Yes.
kilometer per second.
This is the
Yeah,
one
kilometer
the
per
one on
second.
top is the transmission time. That's the microseconds.
Okay, then usually we take 3 test
We
points
take 3 test points on each structural
on
element.
each element.
At least 3 test points. So that's for the first test point. Then the second one. This is the second one now. We save. That's saved already.
There is also option of it saving by itself. And
Then you
also,
press this. Oh. Can you see? Just
so it's
save by
going to
itself.
choose the constant one by itself and it will save.
That's saved already. So do you get that?
The average of the three.
Yeah, the average of the
Definitely.
three.
That will be done during our analysis.
So you
After
decide
we've
the correlation curve we
downloaded
told you about.
all these.
Yeah.
Yes,
Because this is not the actual strength to
there's a particular software that will need to be installed on your system for you to be able to download this. It's a ProSec software, PL link, and the AMA also has its own particular software. So you use it to download the results. They will bring it to Excel sheet where we analyze everything. They will create our own format for table. They will label the structural elements, get our compressive strength, the distance between the transistors will be there, all the necessary details will be there. They will now put a okay, sorry. I said there's a particular software that needs to be installed on your PC for you to be able to download any details or any raw data from your ProSec Pundit or the Schmidt Hammer. So it has to be installed on the system. Then you connect it with the system. There's a connecting cable for that also. Then you'll be able to access it on that particular software. So from there, you bring your data to the Excel sheet where you analyze, you take the ones you need, you understand? Then you analyze it. we have our own particular type of table that we use for our own analysis. Yes, so there's a template for the company that will shows our analysis. Then after that, we get the comprehensive strength of each structural element. Then we also put the remark based on the assumed strength that we use, or probably the strength of the concrete used on the particular building. If it is stated in the structural element. When we don't have the structural element, there's a standard that we use. Lagos State Material Testing Laboratory. Lagos State Material Testing Laboratory has already changed their own standard for a two-floor building. It should be at least 20 Newton per mm square for the compressive strength. But for anything above that, 25 Newton per mm square. Understand? So then, after getting our compressive strength and for all those structural elements, then we have a section where we put our own remark, probably good or poor. We don't use bad, whether good or poor. Understand? So that will be in the table of analysis. Then we have a summary of everything showing all the structural elements tested. We create our own table, the bar chart, and whatever.
For the column, you check just one face of the column for the front side.
On using indirect, it means we have access
So only
to
just a
only one.
particular piece like this.
So test
Can't go
one.
outside and
But for a building, for a frame structure, you all know what a frame structure is. You can definitely use a direct method.
if it
Understand?
is still exposed and they've not
If it
yet
is still exposed,
erected their block wall, everything.
yeah. So you can use direct or even semi-direct, as the case may be. Understand? So that's that about handling of the pundit machine.
Supposing that we want to test this floor,
Yes.
it would be better we do it from the surface.
Yeah,
Yes.
stop it.
So that's if the soffit is accessible. If it is not covered with POP or there is nothing inside, there is no other membrane apart from the concrete surface on it.
So if it is what we do,
Can you like
Which is we can't test it.
what if you are permitted to
can
like
it be tested with floor?
If you are permitted, if the
Floor
owner or
finish,
the
no.
client permits you
that if you are
to,
spreading something,
No.
that's not no longer
Because it will have affected the strength, the velocity, and the transmission time. Yes, sir. Yes. Yes. The best way to get the best result is to carry out the non-destructive test on the structural element itself. On the structural element itself, on the concrete surface itself. On the concrete surface itself. That's where you get the valid and a reliable data. You understand? And I think Oba mentioned something earlier that what's it called? The transmission time. The transmission time does not actually it's not actually the strength of that concrete. So it's the strength of the concrete might be 20, 25, varying 20, 25, 30, 35, and they will have the same transmission time. It just means that the concrete is good. It doesn't. It is homogeneous. Like there are no voids that is well compacted. You understand? But it is now when you correlate it with that particular strength of concrete that has been you made a research and created a curve for that particular strength of concrete. That's where you correlate the frequency, that time, that transmission time, and the whatever. You correlate it with it, then to give you correlative compressive strength of that particular structural element. It's not just the transmission time that anytime you have so transmission time, then this thing is big and everything. Yeah. Okay. All right.
Joe.
Yeah, I will. So we've done the normal.
They're asking
I was just explaining. The man was asking questions.
Just stop this block now.
Yeah, yes. This is transducer. Transducer. Transducer.
So they asked the question. No, we've already done the test already, so we technically don't need this again. Unless we need one of them to just practice. So, eh? You want one of them? So give it a try. Okay. Hello, guys. I would love one person to come and give this a try. Like, just come and set it up, then use it as we used it here. Just a practical, just a simple practical.
Okay, all right. I think we'll do it like this. We'll not corners here. We're not trying this. We're not using this to like we're not using this to like maybe scare us. But the truth is, if one person doesn't try it out, then all we just did here, we're just gonna forget it and just down the drain. So one person try. I'm not aiming that you get it right. What we just need is just try and feel the equipment and then just let it be. So who's going to try?
Oh, are you afraid of
You are
the
not
jet?
going to try. You want to just
I'll carry the
weight
on my neck.
Yeah.
That's weight on my neck.
So it's more expensive than that. Though.
so you can just go with it.
Or you can test it on that particular one. Since we did it here earlier, let's do it on that one.
You can do it on that.
No, it's calibrated already.
Don't go too far.
And let them use that one.
So I go to measurement, have you?
Yeah,
Yes,
measurement.
measurement.
You can, if you want to rename.
Hold on.
Wait, you can.
I have to like add
Can I even
another name now.
continue?
Assuming you are doing direct now, you have to change. You have to measure it. Let's say this direct now. You want to put your transducer here or here. So you have to measure this length because it's direct. Yes. But now we are using the indirect. We're always using 120. So that's why it's still 120.
You have to be very odd. So, all right. So, I think the first thing you're going to do is, assuming you're giving this now, you've renamed it already. Can we just have one class? You've renamed this already, right? You renamed the column you want to test. So, the next thing you do is you just hit this clipboard.
No, we don't.
You renamed it, right? Just play. Yeah. Now you can hear the ticking sound. Now you put it, just go ahead. Don't be scared. All right. Now, when you put it here, let's just sit down. Don't worry. I'll be very audible enough. Can we just ask? Now you don't need to press it like just hold on. Now, is this up to 120? The path length between this transducer from center to center should be 120 mm. Right? If you want to get it, I don't believe it's up to 120. I bet you over and over. You don't want to. So you can just use a tip.
Yeah, this is it. Phase one of it on it. Center to center. Can you see this first center?
Yeah.
This is 120 here. No, yeah, now. Yeah, after that 10, then 2. That's 120.
That's 120. All right. So this is 120 mm. So when you check your transducer, what's the transmission time
You're
you are
not pleasing
getting?
today.
Just focus there. The transmission that
Automatic
you are
one
getting
is this one, Abi.
You know what?
The automatic.
Yeah. No. This is automatic. Yeah, this one you are saving. This infinity stuff. Yeah.
So here now it's just telling you that
Let's
your
just see.
transmission time is around
Yeah. It's camera.
3.8. So you click on the camera, you save it, you capture that. Then you go to the next point, right? You just move downward.
Move down.
Move down with the
Put your hand there. Yeah.
What's the look called again?
Co-plant.
Coplant.
Yeah. No. Put your hand there.
The look is called coplant.
Co-plant.
Don't worry,
See,
it's not a chemical, it's friendly on the hand.
put it very well because the surface is rough. Just
Yeah, you can't leave this. You are good.
no, shift it a little bit.
No.
To the back. Yeah.
Oh, yeah. All right.
You have to check that it's consistent. If you are not sure that you can change it to
From like
you
24
can change it to automatic. Remove it. No, remove the second one too.
That will be the last one, and then we can just.
See too. Last time
You have to go in any sequence, like up, down, and middle.
You can go in any sequence.
So let it be more space. No, actually. Shift it in, yeah.
Center to center.
That means from the center of the transducer itself.
So it will say by itself. You didn't press anything. So
All right. So I
So
think
my question,
all right.
to get the comprehensive rate of
Yeah,
this,
we can stop.
as you have said, that we're going to compare the transmitting time with
Let's
that
go.
of our model.
the UPV, pulse velocity.
All right.
Okay.
You can bring it.
Pulse velocity. Yeah, it's showing. UPV test. Yeah. You put in your model, the position curve you have already conducted yourself. You put inside that equipment.
All right. Thank you very much for those. Let's give them a round of applause.
You have to use your very
All right. So from here, once we are done from any site, we have what we call a transfer cable. We have a transfer cable where we download all of this information into the computer, right?
Right.
Then you can couple it. We download it into a computer, and then from the computer we can then run the analysis that we need to run to be able to ascertain what strength using the correlation curve that we already have as an independent lab, right? So I think that's about that for what's it called now, for the UPV. That's how to carry out the UPV to set it up. And when we are done at site, we just dismantle it the same way we set it up, and we get a rag. Does anybody have any rag we can use? Because this gel has to be cleaned up so it doesn't get very wet. So that can dry up on its own. So next we'll be talking about the rebound hammer. Go ahead with the rebound hammer.
So this is the rebound hammer. This is the rebound hammer. That's the general name, rebound hammer. But this is silver Schmidt hammer. Schmidt hammer. It's written here. That's the person that used this particular one. So as you can see, we have different parts to it. We have the plunger, we have the
Oh.
No, it's record.
Oh, for it?
Yes.
Thank you. So we have the
Can get
plunger,
right from the car.
we have the USB ports, we have the LED screen, we have the select button, we have the casing itself. So all these makes up the silver Schmidt hammer. So you power it on with the select button. You only have one button on it. So you have the select button. Now there are some functions that are displayed on this Schmidt hammer, and there's just very few and very simple way of handling the Schmidt hammer. We have the tilt, we have the roll, we have the select, yes, we have the tip also. So on this now we have, I would send probably the manual, not the manual like that, just a step-by-step way to use the Schmidt hammer. So even without seeing this particular Schmidt hammer, you'll be able to see all the things that are on this LED screen, and you'll be able to know what to select and how to use it effectively. But I'll just do the practical aspect for you. So we have so many functions here. We have the single shot, we have the summation. You can't see it easy like that because I'll be tilt. Okay, now for different functions, it's either you tilt, you roll, or you roll front, back, or you tilt left and right. Can you see? So you tilt left and right to go to each of these icons here. So during the practicals, I'll still tell you those things. So we have the summations, we have the single shot, we have the conversion curve, we have the units tab here, we have the form factor, then we have the carbonation. I talked about carbonation earlier, the carbonation value. So in that manual, you understand better while you read everything. So when you want to just test, just want to see what you just want to test the beforehand you have to calibrate the Schmidt hammer, and there's an hand view for that. You didn't break that because it's quite heavy, but movable though. But did not bring the calibrating hand view. So when we try to use the Schmidt hammer on the hand view, there's a particular rebound number it should give us. If the Schmidt hammer is still very good. You understand? That is still considered to be used on site, because while using the Schmidt hammer, definitely it's a device, it's a machine, it's made of mechanical parts. You understand? So frequently or occasionally, while you used it over time, definitely it will have reached a particular place where it cannot function as it used to function before, because you've utilized it to a particular level. You understand? So, excuse me. Thank you. So now, calibrating it now, I can use the tip method. I'll show you how the tip method works. The tip method, let's just assume this is a concrete surface. And while you are using the Schmidt hammer, your Schmidt hammer and the surface you are trying to make impact with needs to be at a right angle. It needs to be perpendicular to each other. That's 90 degrees. It needs to be straight. Not like this. Not like this. Not to the side like this. It needs to be exact, like either vertical or horizontal. For an horizontal surface, your Schmidt hammer needs to be vertical. Excuse me. But for a vertical structural element, your Schmidt hammer needs to be horizontal. You get that? So while testing the columns, you use the vertical method. But while testing the beams and the slabs, you use the no, you use the vertical. You understand? So, and overall, while using the Schmidt hammer, while you are testing the part, and keeping in mind that Schmidt hammer is only used to test the surface hardness of a concrete element, surface hardness. And you all know that surface hardness can be influenced by carbonation also. So there's a factor of carbonation in this Schmidt hammer. But mainly it is used for concrete surface alone. Rendered surface, it's a no-no. Any finishing that is done on a particular concrete surface, you cannot use the Schmidt hammer again. So it's only when the construction is ongoing and all the structural elements are still exposed, that's when you can use your Schmidt hammer. So now we have the units, we have the curves, the conversion curves, we have the form factor. The form factor talks about this is the cylinder part. Then this we have the cubic one, the cube one. Then you have the user defined. You define it, probably the type of structural element you are trying, the shape it is. You understand? So then mostly we use the cube. Then the carbonation also we use one. Then the units we use Newton per mm square per unit. So we select everything there. And it is said that for each test on every structural element, you take at least 9 shots. You make 9 impacts of the structural of the Schmidt hammer, at least 9. But for scab, we use 10. You understand? And there is a particular section, there is a particular place here on the Schmidt hammer where you either select the form at which you sum your or how you get your rebound number and your compressive strength. Is either you use the American standard method or you use the median. You know, when you are using 9 shots, then it will definitely be the fifth shot that I use as the rebound number and the compressive strength. But we will use the mean. We use the mean. So this is the mean now. We use the mean. Then after making 10 plunges or 10 shots, we have we check the average for it. Then it creates a rebound number and the compressive strength. It will be displayed on this particular LED screen. But you can do as many as possible shots on this on different structural elements. But the thing is, you have to record the numbers because we have rebound number also. You understand? We have impact number. We have impact number. So it's just a sequence of, okay, from I made 10 shots and the starting point is 1048. Then the next one will be 1058. So that's for the first 10 shots of one particular structural element. Understand? Then you take note of that, write that down. Then while you are downloading your readings, then you're able to locate which rebound number or which rebound value is for this particular structural element, then use it to analyze, do the analysis. So now, for each structural element that will be tested now, I'll be making 10 impacts. We have, okay, I will show you the Q value, that's the rebound number, the impact counter, then the 50th value, whatever, everything. I will show you why after I've done the 10 impacts on the structural elements. So let's just assume this is an unrendered surface. I want to check for the surface hardness, yeah? So now, whenever my hand slips down or up, let me know. Understand? So it needs to be horizontal, like near 90, if not 90 degrees to this particular distance. So the angling also matters. The handling of this particular element also matters, because you cannot say you want to plunge into this particular structural element and you are like this and you are shaking, you are taking your time. No, you can't be too fast also. You can't be too fast also. So it's a, let me show you this. That's one. Can you see? Number one, that's the first reading, then the rebound number. Then if you see these three, you guys can't see it, but I'll say it in the video here. So you can see this place where we have 3 points here. That's the 58th value. You know, this thing is almost 50. It's almost at 50. So anything exceeding 50 will be after this. So this particular this thing here, this 3 value, it means 58th value. You understand? So this is the rebound number, this is the Q value, then the impact number. Yeah. So that's for the first one. 2, 3, 4, 5, 6, 7, 8, 9, 10. Can you see? Now it is showing summation. Is that I sum everything together, or I delete this particular 10 series of numbers. So I will now have to sum everything. Then it will display. Now this is the mean average rebound number. Understand? This is the standard deviation. This is the rebound. This is the impact counter. This is the number of impacts. You understand? So all these things, you definitely find it in the manual I'm going to send. So now look at this. Look at this. This is the average compressive strength.
Okay.
2.5.
Average compressive strength.
So this is the carbonation one.
Yeah.
Yes, we still use Excel for it. Carbonation factor. Everything is inside that what's it called, that manual I'm going to show you. So that's that about this. But the computation is just the same thing as print it also. We already have a curve for that also. So it's just a correlation between everything and you understand. Then keep in mind that the rebound number is not the same as the compressive strength. But the higher the rebound number, the higher the compressive strength. You understand? So and he showed you a table. He showed you a table showing that earlier in his own presentation, where he showed the pundit and the rebound hammer. So he showed you that 40 upward or 50 upward for so particular. You can bring out that particular table again. So that's like even with your Schmidt hammer, you definitely see the compressive strength. Like when you are using it, you will see it. But either ways, when you are trying to compute everything using any type of we have different types of curves on the what's it called, the Schmidt hammer. So we have the one that it is we have one that is the 10 percentile. We have the one that is curved China. Different curves, different curves, different curves. We don't want to go into the analytical parts today, so we have different curves for it. So that's when you bring out your values from the Smith hammer, you correlate to the curve, create a table for it also, then you analyze it. Then after that, if you have actually done probably UPV test on the building also, but you feel it is inconclusive, then you use the rebound hammer, then you create, that's when you use the sun rep, that equation, sun rep, that's the sonic waves and the rebound number together, then you get your final answer on that. So, do you have any questions? Lastly, I would like to emphasize this. I would like to emphasize this. Non-destructive testing should be done on concrete surfaces. Concrete surfaces alone, like concrete surfaces. That's when you get your accurate values. That's when you get your accurate values, nothing else. Thank you very much. You want to add anything?
Thank you so much, Team Scarp Conduct. We really appreciate what you have fed us with knowledge. Yes, that we will continue to build on. Okay, so the discussion continues. That is to say, the engagement continues. You can see how how well they dealt with the knowledge dissemination this afternoon, and they are ready to welcome any form of engagement thereafter. They are accessible. You can have their contacts. So the discussion continues. I know some of you can see that. That is what they do. They have carved a niche for themselves. So you can also join their team and become experts when it comes to NDT. There are so many areas that we do NDT. From my own little knowledge in oil and gas too, we do it on most of the oil facilities. Pipelines, when you install pipelines, okay, you weld the joints. We also do series of NDT on pipelines, on welds generally. Okay, so you can carve a niche for yourself and build more knowledge for you to be able to function appropriately in the industry. So on this note, let me give one of you to give vote of thanks. Who should do that?
I'll do it.
No, not you.
Okay, good afternoon, everyone. So, on behalf of the students of the department, I want to thank our facilitator, Scarp Consult, for their time and sharing their experience with all of us. We also want to thank our our lecturer, Dr. Shingi, for bringing this kind of initiative to come and to invite the industry to come and talk to us and teach us about NDT. Then lastly, I want to thank the students for their time, because if you guys didn't come, we won't be able to hold this program. So thank you very much.
And also, we want to thank our sister, our student.
Nazia.
Oh, exactly. This is our exactly.